Good evening. I hope you all doing well. Okay, we'll start for the day. Shashank sir, you can take over the class.
Sure, ma'am. I'll start. Good evening, everyone. So, welcome to day 30 of our program. So, I've shared the data set in the chat. So, you can just download the data set. Okay. I'm sharing it again. Those who have not, will just join now. Fine. So good evening again, and let us start the session. Okay. So today we'll discuss about deep learning and the implementations of two main frameworks and two main libraries in deep learning, which are Keras and TensorFlow. So we'll discuss that today with help with a project around. Okay. And then we'll do the NLP, and then we'll have a session on the capstone project, how to have some ideas and how to implement a capstone project, and how a project uh, can be deployed using Streamlit and Flask and all. So that we will see in one session, right? So let us get it started. Let me share my screen. First, let us understand what exactly is deep learning, and from there we'll take it on with a project. Okay. So let me share the screen. Right. Okay. Fine. So let us understand first what is deep learning. Okay. And why deep learning is very important when it comes to implementation into AI systems, right? First of all, the most important thing is deep learning is nothing but the subset of the machine learning part, right? Now, to understand deep learning, the main important thing we have to understand is the concept of neural networks. So neural networks is something where you can understand where from the human brain, okay, or the real life neurons. So it has been mimicked, or it has been built in such a way that how a neuron actually functions in a human brain. So in the same way, a neural network in an deep learning functions. So it's the same mechanism in which the way of how this neural network has been actually built. Okay. So let's keep it very simple. That what exactly is deep learning, and why we are learning this two important frameworks and libraries, which comes to the picture when we talk about deep learning, right? And why deep learning is being spoken hugely, or why it is into the limelight. Why it is into the limelight basically is its ability to handle huge amounts of data, or you can say a huge amount of data, or huge complex data, right? And the way it performs, right? The way the algorithms run and the way it handles is actually the most important thing, and that is how deep learning comes into the picture. Now, let us see some of the key components in deep learning, right? So the most important thing which we speak about is the neural networks. So that we call with a name called as artificial neural networks, because those are artificial, which are created by using the how the human brain actually functions, right? So human, how the human neuron functions. Based on that, artificially a neuron has been built, right? So that artificial neuron is basically called as a neural network. So when we talk about the layers in the neural networks, there are three important layers. One usually, which is the input layer and the output layer. Apart from that, we have something called as a hidden layer. That is what makes neural networks so special. So it has something called as a hidden layers, right? So how deep or how many layers are there between the input and the output is what actually, you know, so that's what actually, uh, identifies that how deep that particular neural network basically is, right? So the hidden layers actually, identifies that, we are calling it as deep learning, right? So what is deep inside deep learning is the number of hidden layers inside that neural network is basically called as a deep learning. So next, we have something called as activation functions. So activation functions are basically something, you can simply, in a simple way to understand, activation functions are nothing but the mathematical and statistical functions which come into the neural networks, right? From one layer to the other layer. So why activation functions are very key compared to some of the machine learning algorithms in the deep learning, some of the machine learning algorithms is activation functions have the ability to capture the non-linearity in the data. So that means, if the data is non-linear also, so we have many algorithms which can handle linear data, right? So what if there is a lot of non-linearity in the data which has to be handled? So for this, right, we need a stronger, activation, I can say a stronger function, okay? Let us not say it as activation function now only. Sure, sure, I'll just share. Yeah. Mhm. Sure. Fine. Okay. So to bring in the nonlinearity or to handle the nonlinearity in the data, right? So especially with the data sets which they are more nonlinear, right? So there we need a function. But what is happening is one function cannot handle the entire nonlinearity in the data set. That particular function is not able to capture the entire nonlinearity in the data. So that is in where the concept of activation function comes into the picture. So basically, what these activation functions do is it captures the nonlinearity by one function from one layer to the other. So we are not talking about the input to output. We are only talking about one layer inside the entire neural network. So it might be 100 layers. It might be, from one layer to the other if you are framing one activation function, right? For example, let us say these 100 layers have different activation functions. So they have the ability, it will not happen. You don't have 100 activation functions. But generally, just if you imagine, the one layer to the other layer, there is, a different kind of function which you need. So let us say you can frame 100 activation functions, right? And you can predict the input to the output using these 100 activation functions. So instead of using one or two functions to predict the output, we are using some 100 activation functions or 10 activation functions or 20 activation functions to predict the output. That's what makes the neural network so special. And that is why deep learning has more accurate results compared to the traditional machine learning algorithms. And here you can see some of the functions such as ReLU. ReLU is nothing but the rectified linear unit. And then we have the sigmoid function. So sigmoid function, it's not new. You have seen the sigmoid function in logistic regression, right? So tan H function, H indicates the hyperbolic functions. Okay, they are basically the trigonometric functions. So tan H is the tan hyperbolic function, and then we have the softmax, right? So these are some of the activation functions which we have. In ReLU, we have again leaky ReLU. Like that, we have different ReLU functions also that we will come across when we build a model. So next is the training process, right? So in the training process, basically the data flows, right? And errors are basically adjusted and all. So that is what the forward and the backward propagation is. And these are basically optimized by using different algorithms, or you can say optimization algorithms is the correct word, like the stochastic gradient descent. And I told you about, when we have discussed the XG boost, I told you about the gradient descent, and I told you gradient descent is a very important concept, which will actually, even when you move to deep learning, it will, it will come. I told you, right? So the gradient descent is part of the, the most important optimizer. What we use is the ADAM. Okay, so adaptive, learning, right? In that ADAM also, it's actually an updated concept of gradient descent only. So that is why you need to understand the gradient descent, not only just for the ensemble technique XG boost, also for the deep learning, optimization algorithm, which is ADAM. So the most popular architectures which you are seeing kind of right now is the CNNs, RNNs and all. So, many would have been already familiar with the CNNs, which is the convolutional neural networks. And then for basically the CNNs are used for image processing or image data. And you have the RNN part, which is the recurrent neural network. This is basically used for, understanding, or processing or analyzing the text data. Or you can also say that for the time series data, something which comes in a sequential order, actually. So which uses that sequential order. Images doesn't use that sequential order. So that is why we cannot process image data for RNN. That's simple reason, because recurrent neural networks are basically based upon sequential data, particularly like the text and the time series data. And apart from this, apart from these two big ones, we also have the concepts which are, the transformer models and the generative adversarial networks. So these two are part of Gen AI, right? So these are part of generative AI concepts. So the transformer models are basically used for NLP tasks like the BERT and the GPT. So you would have, I'm aware, I feel that you are aware of the LLM model, which is the chat GPT, right? So chat GPT is a transformer model. Okay, so it's actually an LLM model, which is large language model. Now, next is the generative adversarial networks, which are GANs. These are basically used for data generation tasks. Okay, so I'm not going to go deep into these things, because these are, high level, and which are part of actually Gen AI. So when we discuss about Gen AI, we can, talk about these things, but not, in the applied machine learning area. So next is the importance of deep learning, right? As I already told you, the way the deep learning works, right? So building the ability to handle huge amounts of data, the ability to build a model, the ability to classify, or the ability to do the regression part, the ability to adapt or handle a huge amount of data, and also this ability to handle the multiple layers of multiple layers of processing, right? And multiple layers of processing, right? And I can say these activation functions, right? Multiple networks, and all these things makes the deep learning very strong, right? And very good. In one way, I can say very strong and very good. So let us see some of the use cases quickly. So first of all, some of the use cases for image recognition, particularly you can think of, is the, if you say image, right? So we talk about the CNNs, right? So convolutional neural networks, right? That is the method or the concept what we use, right, for images. So it actually, we have a technical, one more technical term called as a computer vision. Okay. Now, this is basically used for, medical diagnosis, image, whatever image comes under the picture, where you can use that. So some of the models which you actually use is this ResNet, EfficientNet, and YOLO, right? So you only look once. Okay. So these are some of the models which are used in computer vision for processing of deep learning for images. So next comes the NLP. So whatever is related to the text, like the chatbots, virtual assistants, right, and customer feedback, right, sentiment analysis, and machine translation, like the Google Translate. So everybody knows Google Translate, right? So you can take the GPT models, BERT models, all these things comes into the category of natural language processing. So next is the speech recognition. Here you can see the voice to text conversion. And then you have the virtual assistants like the Cortana, Google Assistant. You have the Samsung's Bixby, right? And you have, Vivo's Jovi, right? So you have many speech recognition voice assistants which are available in the market, right? Right from the smartphone company to the, big companies, whoever are using, right? And some of the examples are the deep speech and the WaveNet, which are the models which are used for the recognition. So next in healthcare, so we use a couple of models such as DeepServe and the AlphaFold. So this is basically used to do the surgeries using robotics, right? So drug discoveries, right? All these comes into the picture for the healthcare domain. So next, we'll go with the autonomous systems where you can see the processing through the navigations and all those things, right? So using the CNNs and RNNs for CNNs for image and RNNs for the time series navigation. So next in finance field, so finance field is something where we try to predict the fraud detections. So whenever we identify or whenever we see say finance, the first thing that comes to mind is basically the fraud detection, right? That is what mostly I can say, instead of fraud detection every time, you can also say that risk assessment also or risk analysis, right? How much of risk is there? It might be anything in giving out the loan or recovering the loan or anything. We have the risk assessment or the risk analysis, what we can do, right? And here we are using some of the models like the LSTMs, right? LSTMs are nothing but the long short-term memory. Okay. So these are basically used something for time series data. For example, even for the text data also. So text data uses the LSTM models as well. So next is the recommendation systems. So particularly when we talk about the recommendation systems, everybody would have already guessed, right? So you can remember the recommendation systems either in the e-commerce or maybe in the OTT platforms as well, right? So you can you can take the examples of Amazon Prime. You can say think of for movies, and you can also think of Amazon's website where you get the personalized recommendations and all, right? Next is the content generation, right? So content generation is basically something called as a deep fake. So this one you would have already heard. And then we have the synthetic data. So synthetic data is basically a data which is created for training purposes to build a model, right? So we create a model in such a way that the model will be learning all the important aspects what are required for building the data. That is what exactly the content generation is. So now the generation of Gen AI, right? Our GPT models and all also. So the advanced models, right? You have a pay version of ChatGPT, right? So the advanced models in ChatGPT can also give you the content generation part. So what it does is, apart from what is there in the internet, right? So what is there in the internet, it picks and it generates the text, whatever it is available, right? So whatever it is giving basically is what is there in the internet. Apart from that, apart from that, right, the advanced models are basically also built in such a way to generate the content, right, based on what they are trained on or what they are actually trained on, right? This is what this Gen AI is basically, one part of Gen AI, I can say, this content generation, where something which is not existent, right? And that is what actually our research and development is actually going towards. So something which is not existent, we have to generate and give, like the synthetic data set, what we are actually doing, right? The synthetic data set, what we are creating for, when we don't have the actual data and, you want to train the model in such a way that your model has to predict, right? That isn't where people are going for creation of synthetic data set. So synthetic data set will become common, or it will become I can say, as a very important aspect, right? When it comes to real world, when it comes to the data, data set generation, in the future as well. So already people are using the synthetic data sets, and apart from that, it will become more common when it comes to the future. So next is the concept of robotics, where robotic. When we talk about the word robotics, it is little physics and electronics is also comes into the field when we talk about the robotics part. So next is the gaming. So gaming such as the OpenAI and the AlphaGo, right? So these games are designed in such a way for creating a environment for already you would have already known that simulation gamings and all which already have been processing in the current generation. So next, let us see the implementation of deep learning, right? And when it comes to deep learning, the most important part, what we also speak about is the GPU part. That is where the hardware also comes into the existence. So we'll talk about that. So tools and frameworks, the most important one is the TensorFlow, right? So it's an open source framework actually, which is actually developed by Google. So TensorFlow framework is actually developed by Google's Brain team. Okay. And then we have one more, which is the PyTorch. Pi indicates Python. Okay, Python torch. This is actually a framework which is designed for using these deep learning tasks. And then you have the Keras part. So Keras is nothing but it's a prototype or an application interface which is together used with TensorFlow. Now, actually, this Keras has been merged with TensorFlow, and Keras and TensorFlow together we are going to implement. And one more framework, which is ONNX, which is open format for interoperability, between frameworks, right? Now, coming to the hardware part, what we are talking about. So we talk about the GPUs, right? So here you can see the GPU companies like the NVIDIA, right? Also, we have the AMDs also, right? And these are basically used for accelerated training and performances and all. Okay, so TPUs are nothing but the tensor processing units. These GPUs, which actually use this technology of ray tracing, have these TPUs, which are also called as the CUDA cores. Next is the cloud platforms. So next is the cloud platforms. So the platforms such as AWS, GCP, and Azure. Okay, so AWS is Amazon Web Services, GCP is Google's cloud platform, and Azure is the Microsoft Azure. So these are basically used, which they support hardware through the cloud. Next is the deployment. So the projects or the models which have actually built has to be deployed, right? So either we are using the service of TensorFlow or we are using the PyTorch. We are deploying it into the real world. So basically, these are the shorter steps how to prepare the data, process it, and design it, train it, and evaluate, right? And then deploy it into the real world. So it's not that easy how we just talk, but it's a simple process. What exactly on the whole it happens. So challenges in deep learning. The most important thing is getting the data set. That is why content generation has played a very important role. That is the reason people are now in the industries also trying to generate synthetic data sets where the actual data sets are not present in many challenges. So people know that which kind of data set has to be generated. So that is in where the synthetic data sets are actually generated. Okay. So these synthetic data sets actually help you to, actually help you to process. These are actually making life easy for building the models, and you know what you require, and what to predict, right? And how you can do this by creating a model, right? So that is where the synthetic data sets are playing a very vital role, because there is a problem of getting large data sets, because for deep learning, right, you cannot get a very good accuracy if you build on small data. For example, for machine learning, you can use maybe a small or a decent size decent sized data. But for deep learning, it's not like that. You need a huge amount of data, which actually, sometimes it is also difficult to collect as well. So next is computational cost, and because deep learning needs a lot of, performance, kind of, maybe, I can say advanced hardware, right? So the cost of building, maybe a computer you can think of, right? Because as I already told you, we need a lot of GPUs and we need a lot of TPUs, right? So it costs a lot. So that is what the computational cost is basically about. And then we are, sometimes what happens is black boxes are nothing but, an environment which is used for testing, which before deploying into the project, right? Testing the projects. So this is one big area. Is also a concern when it comes to the deep learning part. And then the biasness in the data, right? That is what some of the ethical concerns what we have when it comes to the deep learning part. Next is the overfitting, risk of memorizing trained data instead of generalizing. So our model has to basically generalize, right? So if it is able to generalize, then it is easy to predict, and it is easy to see it on or test it on the unseen data. But when it comes to this overfitting part, right? If that is not it's not able to it's not able to build a model by reading the data properly. So if that actually that thing happens, right, it is very difficult for us to predict the or generalize for the future data. So let us see now what is Keras. Okay, so we have just seen on our over note that what is deep learning, what happens in deep learning, what is right. So let us see some of the aspects. So first, two things we have to discuss. One is the Keras and one is the TensorFlow. And the first one is let us start with Keras. So Keras is basically an API. So API is nothing but an application interface. So it's a high-level deep learning API. And this is basically running on top of TensorFlow, Piano, or Microsoft Cognitive Toolkit. So this CNTK is actually developed by Microsoft. Then TensorFlow is basically from Google. So as I told you now, since TensorFlow 2.0, Keras has been integrated into the TensorFlow as its official high-level API. So next is key features of Keras. So Keras is actually designed, it's a prototype which is used for experimentation, and it is a backend support, right? And it runs it helps to run TensorFlow, Theano, and CNDK. So these are the three deep learning frameworks what we have in the market kind of right now, right? And it actually has a good, I can say, in a simpler way to understand, it is actually a very good architecture, right? Which is basically used for transfer learning and so on. So it is used for many things, and it is ideally very good for the transfer learning, right? And let us go to the core components. So in the core components, if you have to understand what is a Keras, so obviously how a TensorFlow has the same way the Keras actually has, which is the building stack models, functions, APIs. Then it has layers, optimizers, loss functions, metrics, all those things. I think some of them you already know, which is like in loss functions, the MSE, cross entropy, and in metrics, already know the accuracy, precision, and all. But optimizers, you have not come across this Adam, right? So Adam is one of the optimizer, and then SGD is nothing but the stochastic gradient descent. And then we have the layers. We use the dense convolutionally 2D layers, LSTMs, like the long short-term memories, etc. RMS prop is also there. So advantages is, it is its architecture itself is very helpful, and it creates more user friendly environment to build models and to create more layers, right? So that is what the advantages of basically Keras is. So now let us see in short what is TensorFlow. So TensorFlow is a basically open source end-to-end machine learning platform, which is actually developed by Google, right? So as I told you, Google's brain team is the sole proprietor, and who has actually developed the framework called as the TensorFlow. So it is basically a ecosystem where it is used to train, deploy the machines, right? And to do the mathematical computations. Basically, tensor is nothing but an array. Okay, so a flow of arrays is basically called as a tensor flow, and you can see that why it is called as a tensor, because arrays, you have another name. I can say it's a kind of array. So why we call it as tensor, because already array is a name, right? So basically, why we are calling it as is multi-dimensional arrays are basically the feature of tensor. So when we say tensor, we call, the thing what comes to mind is not just array, but a multi-dimensional array, right? So the ability to handle multi-dimensional arrays is what TensorFlow basically is. So next is the key features. So the most important thing is the GPUs, TPUs, and CPUs. right, which comes to the picture when we talk about the deep learning aspect. So these are some of the frameworks, right, which are actually the TensorFlow is actually using the TensorFlow Lite, JS, right? JS is nothing but the JavaScript. So now let us see the core components, right? And as I told you, tensors are nothing but the multi-dimensional arrays. It's like that is why we are not, tensor is not array actually, right? Multi-dimensional arrays is what called as tensors, right? So the ability to handle multi-dimensional arrays, because arrays are faster to compute, right? So that is why, this technology is very successful, right? And they have that connectivity and how they work, right? So these modules like the TensorFlow Hub, Model Garden, datasets, these are very efficient when it comes to processing of the tensors. Next is the advantages of TensorFlow. So you can say the ecosystem is very big, right? So this TensorFlow supports multiple languages like the Python, Java, C++, and the JavaScript. So now let us see the use cases and then let us move the project. I hope you have downloaded the dataset as well. You're ready with the dataset, I guess. Fine. So now let me also share, let us first understand what are the use cases. Let us quickly go, maybe 5-10 minutes. I'll just, we proceed with the project part. So, some of the use cases which these, Keras and TensorFlows help us are basically in the image processing part, where we can process through different, just give me a minute. Right. So some of the use cases, what we can process is basically in the medical imaging, e-commerce, right? And how actually these Keras helps in, how Keras and TensorFlow is actually helping in that particular, which kind of models are actually used. That is what this example is all about. So you can just read it later and you can understand that it's not a problem. Just overview, I'll just give you what is happening in the market. So NLP is basically for analyzing the text, right? Building a chatbot, sentiment analysis, text summarization, speech to text. So right, for that we have whatever sequential models are there, like the RNNs, GRUs, LSTMs, all those can be used for using for NLP. So next is the time series forecasting. So we use the LSTMs and the GRU models. So time series we are already aware of, which is predicting something which happens in time, like the weather, stock prices, sales predictions, and all those things. Okay. So next is the recommendation system. So recommendation system, I've just given you one. Either it might be a social media, or it might be any e-commerce website, or it might be a YouTube, any kind of application where you get some recommendations, right? Based on what actually you talk about, right? So that is what. How do you use a particular application? So usually when it comes to recommendation systems, the first thing easy to understand for people is the e-commerce, right? So you have based on your purchase, so recommendations for you, the movie you watched based on that recommendations. So this is the common thing which has become, with the usage of machine learning and deep learning. That's why they say everywhere we are using this technology, because wherever possible way, wherever we can use this, people are, organizations or industries actually using them. So next is the generative models, like the generation of synthetic data set, which I already spoke to you about. So deep fake creations and all those things. And yeah, mostly that. GAN, we have just talked. Yeah, generative adversarial network. So this is basically used for particularly generative models. That is what generative AI is about, right? So this is what generative, something which you are generating which is not existent. That is what generative AI is basically about. So next is the speech recognition and the process. So here you can you can figure it out that you're using different uh, assistants, right? Applications which can convert text to speech, speech to text, and all those things, right? So next is the medical diagnosis, right? So ability to detect different diseases, right? And the ability to handle different models where you can understand by the images that what are the chances for getting a particular disease. That's where we use the images of a particular disease or maybe X-rays, right? All those things, and X-ray scans, yeah, and maybe yeah, we take scans, right? So that is what we can use, or any but particularly brain scan, right? All those things to identify a particular disease, you can train and you can use the images. So which is helping the medical diagnostics part as well. Next is the autonomous vehicles. I think you are already aware of what is an autonomous vehicles and how it is, how the technology or how people are trying to achieve things in, building this autonomous vehicles. So fraud detection, particularly for finance, right? Insurance claims, e-commerce transactions and all. We use the different Keras and TensorFlow models, right? So for Keras, we are using the autoencoders, and for TensorFlow, we are using the Bayesian models for probability detection. So next is robotics, particularly for image, we are using the CNN models, right? And for TensorFlow, we are using the IoT devices like the Raspberry Pi. Raspberry Pi is an IoT device, right, which is used for edge computing. So next is Edge AI and IoT. So these are basically the sensors which we talk about. So basically IoT devices are nothing but the sensors which can capture actually the data. So sensors, the ability of a sensor to capture the data is basically an IoT device, right? So that we will in that area also we are using them. Okay. So this is about some brief introduction about deep learning. I just touched up. I've just touched up what is exactly deep learning and what are the use cases. Right. On the whole, I've just covered because to explain deep learning only takes a lot of with images, all the models, activation functions, and all. It takes a lot of time and a lot of things. But I kept it very simple because we also need to, due to time constraint, also we need to discuss the project, right? So that's why I think already I've taken up 40 minutes, almost 40 minutes of the session as well. So if I took if I took only a little concepts, just a brief outlet. So maybe you can do some research trying to understand that how deep learning works, and you can maybe develop more when it comes to the deep learning part. So you have any doubt? Maybe some 2 minutes, 3 minutes. I can just take some doubts. Maybe 8:12, 8:15 till 8:15. I can take some doubts, and then I can start the project because we have to finish the project as well. So in the meanwhile, if you have not downloaded the dataset, you can download it. Maybe I'll share the link again. So we can do this downloading part as well as the doubts part together, so that we will, we are going to save some time. So if you have any doubts, you can ask me. Okay. Or else I directly go to the project and we start the discussion on the project. So you can ask me any doubts if you have. Share the project also before discussion. Maybe you can load the project into your computer as well. Let's come on. If you have any doubts, you can please ask me. Maybe I can continue. Let me just go on with the project. So RNN is recurrent neural networks, which is used for processing of sequential data. So sequential data is nothing but something which is in the form of a like a time series, right? So maybe time series data you can consider as a sequential. So we have done one time series project as well. So you can just imagine you can apply times RNNs for that particular time series project as well. And particularly we use RNN for text data also. So RNN is basically used for text data also because text is always in a sequential way, right? So when you talk in a sentence, what is the what probability you have, right, to predict the next word. So that is what basically that is why RNNs use the probability techniques as well. So they are mostly used on text as well as the time series data. So activation function is basically, it's a fancy word which is used in deep learning. Okay, so they're basically nothing but the mathematical and statistical functions which are used to to identify from one layer to the other layer what is the function which can generate that particular task from one layer to the other layer. GAN is an algorithm. GAN actually comes under generative AI. Yeah. That's why I've kept it very simple, first of all. What is deep learning? What is TensorFlow and Keras? And on top of that, we have some of the concepts. When we talk about deep learning, we cannot avoid some of the things like, for example, this generative learning, or you can say generative or generating the data, right? So this is actually, when you say data generation, if you speak, then it becomes Gen AI. So it becomes generative AI. So all the all the algorithms which are like the BERTs or GPTs, right? GANs, right? The LLMs. All these actually comes under the generative AI part, because these and all are used for generation, for generating the data. So anything else apart from certain questions I got? So I've shared you the IPYNB file. Okay, you can just load this file into your you can load this file into your Python notebook, Jupyter notebook. Yes, ReLU is a part of activation function. Yes, yes, Om Prakash. ReLU is nothing but the rectified linear unit. So we have different types of ReLUs actually. Different types of ReLU, and ReLU is a very important activation function in deep learning. Yeah. Yes. Yes. So ReLU, softmax, then we have the tanh function is also very important. We only use tan function, right? Tan hyperbolic function only in the activations. Apart from that, we are not using any other hyperbolic functions. So softmax, even sigmoid is also very important. So this you have to open in Jupyter notebook. You have to download. Yes, sigmoid is very important, Om Prakash. It's very important. Yes, so sigmoid is very important. That's why, when I told sigmoid function, so first you will use the sigmoid when you start doing machine learning because usually you start learning machine learning first, then you go to the deep learning part, right? No, 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 no. Sigmoid is not an algorithm. Sorry, sigmoid is also an algorithm you're asking? No, sigmoid is not an algorithm. It's a function. It's a statistical function. Yes, which is generated from the linear regression line, which is y is equal to beta naught plus beta 1x. So for that, we apply the derivatives and we apply the partial derivative and full derivatives, and we calculate, particularly sigmoid. It's sigmoid, not sigmod. Sigmoid it is. Sigmoid, sigmoid. So sigmoid is basically a function which is used for non-linear data. So if the data is non-linear, sigmoid works really well. And one such application, when you start learning machine learning, which you come across sigmoid function, is the logistic regression. So logistic regression is the first algorithm which you implement the sigmoid function, and that same sigmoid function you are going to use in the deep learning part as well. So it doesn't stop there just with the logistic regression. It also moves forward with the deep learning part, and you use the sigmoid function to build the layers in the deep learning model. So from one layer to the other layer, you use the sigmoid function. And as I told, sigmoid, ReLU, softmax are so the logistic formula. It is the same for sigmoid function is sigmoid function, Om Prakash. It doesn't change whether it is deep learning or it doesn't change. It is the same 1 by 1 plus e power minus z. Where your z is basically, you say minus y or z, anything is fine. So basically that is the same formula or the same function, I would say, not formula. Let us not say formulas. We call it as functions. So when you say 1 by 1 plus e to the power of minus y, which your y is basically your beta naught plus beta 1x, which is your linear regression line. So basically you can say your linear regression is related to your logistic regression, but in a different way, because this is a non-linear data. The same function, which is your sigmoid function, same thing you're using in the deep learning as well. So it's the same. It's the same function, yes. But based on the type of data you're going to apply, yeah. So for which layer you have to apply which thing is what we try to apply. We try to understand. So that part I'm not, how to use which activation function at which time, that I'm not covering actually, because as I told you, because of time constraint and all those things, I have not covered some of the things when it comes to deep learning. So just the deep learning explanation will take a lot of time. Okay. So to learn about activation functions itself, it takes a lot of if you have to understand activation functions, you should understand why we are using those activation functions, and then in what scenarios you will use which activation function. Just randomly we don't use an activation function. So there are scenarios in which this activation function has to be used in this scenario. So when to use ReLU, when to use a tan H function, when to use a sigmoid function, when to use a softmax. So these scenarios you have to understand. Then only when you are building a model, you will be able to figure it out which activation function has to be used in which scenario. It needs a lot of understanding. So once that is understood, then only you'll be able to figure it out. Yes. So yeah, first few minutes nobody asked anything, but now so many questions came in. So anybody, so yeah, it's good. It's good to see also that you're asking questions, because I'll be knowing that okay, fine. So these people are listening and understanding. Okay, great. So any other questions? I'm happy to take, no problem. You can ask me if you have any. Maybe you can just put it in the chat. Maybe in the middle, I'll just check. Okay, maybe after 10, 15 minutes, something like that. Okay, so let us get on with the project. Okay, we have little time, so I'll keep it very simple. The project I'll explain to you. On a simpler note, I'll explain. Okay, you can spend some time on that particular project later. Okay, so let me share. Let me share my Python screen. Okay, I hope you can see my screen. Yeah. Right. So now, when we talk about the credit card fraud detection, when we say detecting the fraud using deep learning techniques or deep learning technology. So this is the same IPYNB file what I shared to you. You can also load into your Python notebook, and the data set I already have shared with you, right? And here you can see, let us start off with the most important libraries which you have to import, right? In that you can see some of the libraries which you are already aware of, such as the NumPy, Pandas, Matplotlib, Seaborn and all, right? And you're also aware of the standard scalar also, which is basically used to scale the data, right, using the normal distribution. So that is used in the sklearn.preprocessing. Then we have the model selection. So you're also aware of that, train underscore test underscore split. And then we use the metrics, which is the precision recall and the F1 score. Then we have the models. This is new for you, right? So till now you have seen the NumPy, Pandas, Matplotlib, Seaborn, sklearn, right? All these kinds of stats models and all these models you have seen. One of the new thing what you are seeing here is the TensorFlow, right? So now since the Keras is basically embedded or included in the TensorFlow, you can see that this model building as well as the inputting or creation of layers and the number of dense layers which we have to create. And the most important one is the optimizer, which we are using here is Adam. Okay, so Adam is a very important optimizer. So Adam has evolved actually, through the years from the stochastic gradient. So if you dig deep about what is Adam, okay, so maybe you can do it later. Okay, you can do one Google search on what is Adam optimizer in TensorFlow. So you will see that history goes back to the gradient descent, which I told you about, Augustine Louis Cauchy, right, in the 1847, which he founded the gradient descent, gradient ascent and gradient descent. So it's the history of Adam starts with 1847 of the introduction of gradient descent. From there, it has been evolved and it became, stochastic gradient descent. It has, transformed into multiple gradient descents, more advanced algorithm, and finally into such an optimizer called as Adam. So this is Adam is not just one optimizer. It is a history of 150, 60 years of, gradient descent. So, that is why Adam is a very strong optimizer, which is used in the Keras and TensorFlow, right? And for model building and layer building, we use the input and the dense and so on. So coming to the next part, which is reading the data set, right? So we have a data set. So basically this data set is, you can see a values only here because this data set is basically converted into principal component analysis. Okay. So this V1, V2, V3 are nothing but the principal components. Okay. So principal components I've already explained because I've explained a few things already about PCA, right? Principal component analysis. In that, how the data by using the eigenvalues and eigenvectors, right, and variance covariance matrix, and how it is actually converted into the principal components, right, which are the important components which are useful for the data, which gives or which covers more information which is required to predict the target variable. So, so the data is basically in the values of the eigenvalues, okay? Because since the privacy concerns and all, the data has been converted using the principal component analysis, and it has been given for you in the value of eigenvalues. Somebody, what is the purpose of logistic regression? Okay, so this question, I don't know why you're asking this question now, because I'm okay to answer, but maybe you have not attended my previous sessions. Logistic regression is basically used for classification techniques. It is used for classification tasks to predict a categorical variable. So logistic regression can only do categorization or predicting a categorical variable. It is only used for classification. So it doesn't have that ability. Okay, fine. It doesn't have the ability to run a regression task. So even though there is regression inside the algorithm's name, logistic, it is basically used for classification techniques. Okay, so getting this question out of the way, coming to the data set, where the data set is more given for you in the form of a principal component analysis values. These values are nothing but the eigenvalues. Okay, so now let us go forward to the for checking for the any null values are there in the data set, right? So basically we don't have any null values. So next thing, let us drop the column time, right? Or you can say the time component, because we don't require this time component in the data set. So let us drop this. And now let us give a particular class. Okay. So whatever in the class, which is the outcome variable, you can see here, whatever in the class is basically having 0. We are considering it as a normal data, and whatever is having the value 1, we are considering as a fraudulent transactions. Okay, so we are considering them as a fraudulent transactions. So next thing is once the fraudulent transactions are identified. So I think I'm going a little fast. Maybe I'll just come back to this. So see this one. We are actually scaling the data. Okay. The most important here, what we are doing is we are scaling the amount column. Okay. And we are scaling the amount column. And since the time factor here is not important, we are actually not considering the time factor, right? So we feel that, it is not that important in this circumstance, right? So we are removing the time factor, right? This is not a RNN model, or this is not a, kind of data which can be predicted using the, using the time series models or a sequential models, right? So we don't need that kind of, column which is time in this particular scenario. So next, the fifth line tells you about the identifying or the, so fifth line basically tells you about identifying the transactions where you have in that particular class or the outcome, right? You have 0. We are classifying it as a normal data, and we are classifying the whatever in the class you can see 1. You are classifying as a fraudulent transaction. So 1 means the fraud transaction, and 0 indicates the normal transaction. Okay. Fine. Now, once that has been done, the next piece of code actually tells you about the identifying that, categorizing it into, uh, you know identifying the target variable, which is your y. Okay, so here you can see that y is the target variable. For that y, we are giving the class, right? Because we need the prediction, right? So we want to predict whether whether which kind of class is that particular transaction is all about, right? So we are dropping the class from the x variable, which is your independent variable. We are giving or allocating that particular class to the y. Okay. Now, let us go to the next part. And here we can see that what we are trying to do is we are going to divide the data first into X-train and X-test. Okay. So we'll get to that Y-train and Y-test later. Just wait. First, we are splitting the data into training and testing for the X variable first. Okay. So here you can see that we have given around 80% of the training data. So since we have mentioned 0.2 as a testing size, so 20% will be your testing data and 80% will be your training data, right? So not to have any deviations in the random sampling, we are giving the random state as 42, which is a fixed number for doing the random sampling, right? And then we are using the function which is your train underscore test underscore split. So now next is, let us apply the deep learning technique here. Now here what we are trying to do is, here you can see that we are actually defining a layer. Okay, the most important thing, first we are using the autoencoder model. Okay, and we are creating a particular layer here. So you can see that we have given 4 important layers. Okay, fine. So here dense indicates the depth of the layers. Okay, here you can see 14, 14, 7, 5, and 7, right? So these are basically nothing but the number of neurons in the neural network, right? So how many of layers which are actually given, right? So that is what we are going to consider. That many dense that particular layer is going to go with that many number of neurons. And here we are using the activation function as ReLU. Okay, so for encoding, because basically this autoencoder uses the function called as encoding and decoding. Okay, so it will encode the model. That means it will compress to learn the features in that particular model, and again it will decode to uncompress the whatever is compressed to learn. It will be again recompressed or compressed back or reconstructed back, right? So again, we are converting it into 14 important features, and then to that 7, and again from 5 to 7, and again we are uncompressing your 14 features to the 14 features. Okay, so here to compress it back, after using the ReLU function, we are using the activation function sigmoid here to decode. Okay, so to uncompress back, we are using the right. This is basically the input dimensions. Okay, so here you can see whatever has actually happened. So actually we had around 29 dimensions in the data. So this output will tell you how many have actually been or how many have actually are there at the total, right? So at the starting you have 29 dimensions. Since I've given 14 here, it is compressed to 14. Okay, that only here it is showing. The output is nothing but what we have given. So again, from 14, it is compressed to 7. Okay, and from 7, it is compressed back to 5. Okay, right here you can, even though you have given like this, it will take like that. Okay, you can just interchange as well. So again, after compressing it back to 5, it again compressed back to 7. Okay, that is why I have given it here like this. Okay, decoding. Just let me give one gap. Let me change this switch. No, we can't decode it directly. If you are using auto encoding, we cannot do. There are other models to do. Okay, here I've used the auto encoder model. That's the question. We can encode it. Why we should encode it? See, to answer your question, there are two things which I should tell you. Okay. First important thing is you can't decode without encoding the data. Okay, and you use encoding decoding technique, which is an autoencoder model. Okay, so this is autoencoder model is a kind of model which is used for encoding and decoding. This also is a type of model which will learn. Okay, learn from the data, and it will build a layers, and it will learn from the data. So it's a kind of model. Okay, you can also use different models. I'll show you one more project also, which I've done it in different. I've used a different technique. So yeah, so I'll show you that also. So that also I have. Maybe tomorrow for a few minutes we can see heart disease prediction. We can see. Okay, we can see that project before going to NLP. Okay, so NLP one project we'll do. Just on a briefly, I'll explain this heart disease prediction. Maybe for half an hour, 40 minutes. Just a brief note I'll explain. Then we'll go to NLP also, because I just wanted to do that project also. Okay, apart from this credit card fraud detection. So this one we'll finish off today. Tomorrow, first 40 minutes, we'll discuss the heart disease rate prediction. Then we'll just discuss what is NLP for 5-10 minutes theoretical wise, and then we'll go into a project in NLP. That's what my plan is. So let us see how we can do. Then we'll go with one capstone project on the last day. So that is what for the next 2 days. Right. So now, since I'm using this autoencoder model, right, I'm giving the encoding part. So from the original 29 layers, it has compressed to, maybe you can see here, from the original 29, it has compressed to 14 because I have given the features as 14 here. Okay. So basically the features are nothing but the number of neurons what we are giving, which is the input dimensions. Okay. And from 29, we have given 14, and then it comes back to 7, which I have given here. Then we have given 5. So the compression is basically, the compressions are basically happening till 5. After that, we are reconstructing it back. So we have given 7. Okay. And after that, we have given 14, right? And it is coming back to the original size, which is 29. So that is why for coming back to the original size, we have given the sigmoid function, which is the activation function, the sigmoid function. And this learning rate is the optimizer's learning rate. So usually we give 0.001 or 0.01. So that is the maximum learning rate what we give, right? We see always it is good to give a less learning rate so that the model learns very slowly, because anyway you are using a very good optimizer, which is Adam. So Adam is automatically a very good optimizer which will learn from the data, right? And it will build a model. So here we are using the autoencoder model to compile and generate the summary. And obviously, you know this loss function, which is MSE. MSE is nothing but the mean square error. Okay. So let me go down. Next part is let me train the algorithm first. Okay. So the most important thing is in building and deep learning model. The most important thing is the number of epochs. Here I'm using the autoencoder.fit function to fit the data into the autoencoder model. Okay. And the most important thing, as I told, is the epochs. Epochs are nothing but cycles, right? It is basically one epoch indicates the one cycle, one training cycle, you can say. So the data trains one cycle, it becomes one epoch. Okay. So just for, to understand, I've just given 50 epochs. So usually at the industry level, we go with some 1000 epochs or 2000 epochs, at least 500 epochs we train, right? So that the data trains. Okay. So epochs take a lot of time. For example, see this epoch, right? For one epoch, you can see here 13 seconds, right? And for second epoch, it is taking 10. For 16 again 8. So you can, if you give 1000 epochs, you can add the amount of time it will take. It may take some 2 to 3 hours to run to train the data itself. That is why we need heavier systems when it comes to deep learning, right? Because it requires a lot of hardware, right? And it took me this much of time, 13 seconds, because I'm running on a GPU. Okay, so I use a GPU to run the epochs, but if you use a CPU, usually it takes more time. So I've seen, the same thing takes around some 30 seconds, 35 seconds also when you're running on a CPU. So that is why people suggest to use a GPU when you're particularly using a deep learning algorithms. Okay, so just for 50 epochs and all, it is fine, 50, 100 epochs. So if you're running, at an industry level, or when you're doing a huge project, if you have to run 1000 epochs, 2000 epochs, you need that GPU to render and to run faster. Okay. So coming to the next part, which is the batch size. Batch size is nothing but the sample size. Okay. So shuffling is basically, you want to shuffle the data. So if you give true, it will shuffle or it will not shuffle. Now, and let us validate the data for the X test. Okay. Now, let us go see here. I've given 50 epochs, so it will take 50 cycles. You can see here. See the 50 epochs, how it is run. So every epoch will give you the loss function and the validation loss. Okay. Loss function has to be minimum, because loss is nothing but the distance between the actual value and the predicted value. So when we started, the loss function is around 95%, which is very, very bad, right? Because loss function should be very close to 0. 0.95 is very bigger or bigger number of loss function. So if you go down, the loss function is coming down with the number of epochs. See carefully, it is coming, you have seen it 95, 87, 84, 86, 84, 85, 83, 82, right? And slowly it is coming down again, 82, 84, again it went up, again coming down, right? So if you see 0.83, I was able to achieve. That means still I have an 83% loss function and 84% loss function for the validation loss, which is actually very bad. Why? Because having that much of loss function, the model will predict, in a very, very bad way, because the loss function has to be very minimum, very close to 0. So here we are giving around 83% loss function, just to show you guys how we can actually, how these epochs run. I've taken some 50 epochs to show you. Usually the same project, if I have to implement at the industry level, I will run minimum of 1000 epochs, right, to bring down my loss function. Okay, so I think you can understand what I'm trying to tell you. So now coming down, we plot the training and validation losses, right? So whatever we have built as a loss function, we try to build. So for example, if you see the training and validation loss, you can see it's around some 83%. As I told you, it's not a very good, very good loss function, which I'll be happy, which which I'll be using for prediction. So I will not be happy, because obviously, if I run some 1,000 epochs, still I'm getting this validation loss, then I will be very dissatisfied with what I've used. But since I've run only 50 epochs, I'm fine, because just to show you, I have run this 50 epochs, so it's fine. Okay, so going down with this reconstruction part, here we are creating a threshold value for the training data, right? So we are building a reconstruction error, right? And the threshold value we are trying to build. So basically, this threshold value is built on the number of percentile what we have given. Okay, so because it's a classification problem where you have to predict whether that particular class is a fraud, or whether the transaction is a fraudulent transaction or it's a genuine transaction. So we are building a threshold value, which we do exactly. So we are trying to build a particular value which we are expecting that the model has to be perfect at least 95%, right? So we use the normal distribution function, which is having at least 95% of the data. So the threshold value is basically 1.7915, which is what we got. Okay. So whatever the threshold value, whatever comes above, it comes under yes class, right? It's a it's a fraudulent transaction. Whatever comes below that is a non-fraudulent transaction. So here you can see that we are trying to identify using the testing value, which is your test predicted minus your X test. Now, next is predicting the fraudulent transaction, right? So we are using the class which we have dropped, right? Which we are using to predict the particular transaction, whether it is a fraudulent transaction or not. Here we are using the auto encoder dot predict, because this model entire thing I've used the auto encoder. Okay, so just to give a small understanding of how things work. Okay, so I've taken auto encoder because auto encoder is also one such deep learning mechanism or algorithm which can be used also to do projects as well. So now coming to the plotting the loss function, right? So I've created a histogram, right? Using the Seaborn library, and I've used the matplotlib also for figure size borders and all, for labeling and all. Now, if I plot the graph, you can see that the threshold value, and you can see the normal. These are very down, right? Because the reconstruction loss is very high, right? So the threshold value here, you can see the threshold value, and till here it has come the count, and the normal and the fraudulent transactions you can see here. Okay, so actually to be precise thing, the model is not a very good model, because I told the loss function has to be very minimum when we try to go for a prediction. Okay, so the next thing what I'm going to show you is the classification value. Now let us bring the y. Okay, so till now we didn't use the y. Now let us use the y function to predict. So if your value is basically greater than your threshold value, I already told you that, right? So if it is greater than your threshold value, let us consider and give it as 1. So if we give 1, that means it's a fraudulent transaction. So if your e value is lesser than your threshold value, that means we are giving it as 0, and we are considering as a non-fraudulent transaction. Okay, so next thing is we are giving, this already we have done 0 for normal and 1 for fraudulent transactions. So we are using the NumPy to convert it into arrays, because zeros and ones are arrays, right, when we want to predict the outcome. So next thing is concatenating the value, right? Combining the values, right? And the most important thing here is to identify the precision and recall. So now if you see here, as I already told you, when I have trained this epochs, by seeing this loss function, I told that the model is not good, right? Because ideally I want at least some 1,000 epochs to see that this loss function actually comes down, right? As minimum as possible. So that reflects here. I'll show you where it reflects. See the precision score. Very bad. 0.13 is that means the precision is only 13%, which is very bad. Recall is around 86%, fine somewhat, but when you take the F1 score, because ideally precision, you want precision and recall both to be very good, and because one deal with the variance and one deal with the bias. So you want bias one and the variance one to perform better, at least some 85 to 90%, if not more. So and we combine both of them, and we actually use the F1 score as well for when we combine both of them, which is basically the harmonic mean of both precision and recall. So you see the F1 score is really bad. It's 0.22. So 0.22 F1 score is very bad for prediction. Very bad, right? So you cannot predict a value based on your F1 score, which is 0.22. So that is why I told you also, when I've seen the validation loss function here, loss function as well as the validation loss, which is around 0.83 and 0.84. I told you because of the number of epochs. So I think you're getting where I'm going at, and you can link up that. You can try for yourself. You can change here to you can change this to 1,000 epochs, and you can run and check. Okay, you can just leave your computer like that. It will take some 2-3 hours to run the 1,000 epochs. So you can check that, right? If you're interested, in understanding how things work, you can just do that as well. So you can just run the project again. Kernel, you can just click on restart and run all after you load the data set. And here you can give the 1,000 epochs, right? At least some 500 epochs you give, and you just check how the validation actually works. So directly give 1,000 and just keep it for 2 to 3 hours. It will run, and you can see the validation loss and the loss function and the validation loss. Okay, so yeah, so that you can try later. That is for the later part. And now, since our F1 score is not that great, okay, fine, no problem. Let us, even though, to understand, we don't need a better F1 score, no? So we'll move forward and let us predict by using an unseen data point. When we increase the 1,000 epochs, it will be more accurate. Yes, the more number of epochs, the accuracy will increase, Om Prakash. Epochs is nothing but a training cycle. So you think logically. Okay, let us forget about the word epoch. Maybe that is confusing you. Epochs is nothing but a training cycle. So if you increase more training, right, it will do the simple random sampling. It will train more number of times. It will do sampling, right? So it will take a sample and it will train. And you have given the batch size as 32, if I'm not wrong. 32, we have given the batch size, correct? No? So let me go back. Yeah, we have given 32, yes, as the batch size. That means our sample size is 32 each and every time. So it will, and see, we also given the function to shuffle, right? So since we have given the shuffling, it will shuffle. It will do the simple random sampling. It will take a batch size of 32 every time, and it will divide into samples, and it will train. And that it will do 1,000 times. That is what epoch is. That is why it is taking that 13 seconds, 10 seconds, 12 seconds and all. So each time it will do simple random sampling. It will create a batch size of 32. That many samples it will take. Even though if you have lakhs and lakhs of data also, it will divide. That is in where the epoch training time will increase. That is why you need more GPUs to perform very faster. You give 1,000 and see how much time it will take for you. It will take a lot of time if you are running on a CPU. That is what I'm trying to tell you. So that is why for showing you, I've just taken 50 epochs. Only 50 epochs. This only has taken around, you just add the seconds, 10, 13, whatever I have ran, you can just add them. So it is coming, around some 10 minutes it will take, not even, maybe some 7-8 minutes, something like that. Just for 50 epochs, it is coming that much amount of time. So every time it will create a sample, first of all, it will shuffle, it will create a sample, again on that particular samples, it will train, right? And it will calculate the loss function and the validation loss. Then it will go to the second epoch. This much will happen in one epoch. That is why epochs are basically called as a cycles, training cycles, which will also calculate the obviously it will, when you fit the autoencoder model or any kind of deep learning model, it will start to calculate the loss function and the validation loss. So both should be ideally very less, and both should be converging to nearly zero, almost zero it should be. So then only your model is good, because it is basically your predicted value and the true value are very close by. That is why you're almost getting your loss function or the validation loss near to zero, right? So that means your prediction is really good. Then you can implement on the here. As I told you, it's very bad because it's 83%, 84% is very high. So only 16%, 17% accuracy you can see from what you have built. That's why it shows in your F1 score also. No, in F1 score it is only showing 22%, which is very bad, as I told you. Okay, got it, I guess. Yeah. Okay. So now let us take a particular point on the unseen data point, and on that let us train. Okay, let us train and let us apply first of all converting into a data frame, because the data is given like this as a dictionary. Here we are giving as a dictionary, right? It's one of the data structures in Python. So first of all, from a dictionary we are converting into a data frame using the pandas library. Then we are when we are converting, or where we are applying the transformation, right? So we are scaling down the or we are applying the same transformation technique what we are applied for the data. Then we are converting into a NumPy array, right? And then we are encoding, or you can say encoding or decoding using the autoencoder. Then the same procedure what we have done before, the same thing applies here as well. So then we are using the reconstruction loss, or we are reconstructing the loss by giving the loss function. Obviously, the loss and validation loss both will be calculated. So here we are giving it by giving the NumPy library. And then we apply the threshold function. We have got some 1.7 change as the threshold value that we will identify. So greater than the threshold value, it is a fraudulent transaction. Less than the threshold value, it is a normal transaction. So, and then we apply the label and we run the algorithm. So you can see that the reconstruction is 0.55. Okay. So here you can see 0.55 is less than the is basically less than the threshold value, because your threshold value is 1.777 something, right? So since the value is lesser than the threshold value, it is a genuine transaction, right? Right? Yes or no? Ha. So it is less than the threshold value, so it's a normal transaction. Yes. Yeah. So it's a normal transaction. That is what the prediction is. Okay. So this is what the project is. I've shared with you. Maybe you can just go through it. Okay. Yeah. So this is what the project is about. If you have any doubts, you can just ask me. So as I told, tomorrow, first thing, we'll just discuss this RTC's prediction project. Okay. So this is an actually ECG data set for predicting the heart disease. So let us use this first, and then let us, it may be some 40-45 minutes. Briefly, I'll explain that and I'll share it with you. After that, we can go to the NLP part, which I want to ideally finish tomorrow. Okay, so let us do that. Let us do that tomorrow. Fine. So 2 minutes is there. If you have any doubts, you can ask me, or else by 9 o'clock we can wind up. So I'll just take questions. You can just let me know. Shushmita ma'am, I think there's no questions. You can just take over.
Yeah, sure, sir. We'll wind up for the day if you don't have any questions to be addressed. So yeah, we will wind up for the days.
You can go with 1,000 like that, Om Prakash. 1,500 is an ideal number. It will not overfit. Ideally, the say we do all the EDA process and all those things. No, usually it doesn't overfit. that doesn't happen, particularly with a deep learning model. It doesn't overfit. So you can just try with 500 to 1000 epochs, and then you can check the accuracy of the model. So fine, I think we can wind up. So if you have any questions, you can just maybe ask tomorrow. Okay, in the tomorrow session. Yes.
Yeah, thank you, sir. Thank you for your
Yeah.
valuable class. We'll meet again by tomorrow at 7:30. Okay. Yeah. Thank you, students. We are winding up for the day. Thank you all. Good night.